Hi, I'm Larry Martin. This is GlueLogix. And here is GlueLogix Encode In Motion, processing a test strip of 151 Gen 2 inlays on pitch in 8 seconds. Here it comes again in case you missed it the first time. Each inlay is having the entire EPC and entire reserve bank encoded and then read back for comparison. This is the PC display for that 8-second run, showing serial activity lights on the left, history and status on the right, performance and monitor in the center. This screen shows the data setup for the 8-second run we were just looking at. It works off a substitution code where the capital G next to encode EPC is the gap count, or the ordinal count of the system. The capital U in that same blank is the UID/TID for the current chip. The other characters control offsets, substrings, and the like in order to come up with a final data format from the inputs. Other things that can be put into that string include timestamps and vision data. In order to check our process, we're going to use the Read UHF button at center right of the software. It's going to step the transport through each inlay and read every bank, every bit of data off of every chip. So far, all we're going to do is eyeball it. But the system does have a readback function and a separate verify capability. We use the FIG UHF reader in a configuration that returns the EPC and TID in one packet. On each good chip, the end of the TID value is copied to the end of the EPC value. Also, on each good chip, a constant pattern is written to the reserved bank. The first 4 bytes of each EPC are an ascending number corresponding to the number of gap sensor pulses. You can see that the numbers come out in order, even though the writes on consecutive chips are executed far apart. The second number from the bottom is out of sequence, meaning that the encode on that chip failed. If we were not working with a test strip, that inlay would be marked bad at the end of the line. So finally, watch along while we run some chips from a different take. That was 54, 55, 56, 57 hex, 58, 59, and 5A hex. All good.